The time period, t seconds, of a simple pendulum of length L centimetres is given by the formula here. Katie uses a simple pendulum in an experiment to find an estimate of the value of G. Here are her results. So she has L is 52.0, correct to 3 significant figures, and T is 1.45, again correct to 3 significant figures. We need to work out the upper bound and the lower bound of the value of G, and using pi to equal 3.142. So we're going to be working out the upper bound and lower bound of the value of G. So we want to know what G equals to. So I'm going to take this formula and I'm going to rearrange it so we get G equals something. So first thing I'm going to do is I'm going to divide both sides by 2 pi. So the 2 pi here and here cancel, leaving us with T over 2 pi, and that equals the square root of L over G. Now we want to get rid of the square root here. So I'm going to square both sides. So for this side on the left, if we're squaring all of a fraction, that essentially means we're going to square the top of the fraction, so the numerator, and also square the bottom of the fraction, so the denominator. So on the left-hand side, we're going to have t squared over 2 pi all squared. That's going to equal L over G. So we square something that's square rooted, that gives us what's inside of the square root, so L over G. So now I'm going to multiply both sides by 2 pi all squared. So this leaves us with t squared by itself on the left-hand side, and then L multiplied by 2 pi squared over G. So now we're almost there. I'm going to multiply both sides by G. So that gives us G multiplied by t squared equals L 2 pi squared. Now lastly, let's divide both sides by t squared. The t squared here and the t squared here cancel, leaving us with G on the left-hand side, which is what we want, and L 2 pi squared over t squared on the right hand side. So now this is what we want to work out the upper and lower bound of. Look at G, what's it made up of? We've got G equals, and what variables have we got? We've got L and T. So I need to work out the upper and lower bounds of T and L. So working with L first, we're told the value of L is 52.0, 3 significant figures. So if I do plus 0.1, we're going to have 52.1, and subtract 0.1 from L, we're going to have 51.9. So we're going to use this to help us. What's the upper and lower value we could have had for L, which means it rounds to 52.0 to 3 significant figures. While our lower bound is going to be halfway between here, so 51.95, and upper bound halfway between here. It's going to be 52.05. And you can test this out. Pick any number between 52.05 and 51.95 and round it to 3 significant figures, and you should get 52.0. Pick any number less than 51.95 or any number greater than 52.05 and round it to 3 significant figures, and you won't get 52.0. Now we're going to do the exact same for T. So we're going to add 0.1 and then go halfway between that again. So it's going to be 1.46, and halfway between that it's going to be 1.455. And if we subtract 0.1, we're going to have 1.44. And if we work out what's halfway between this and this, we are going to get 1.445. So here's our upper bound, here's our lower bound, and again we can test that, because any number within this range here, round to 3 significant figures, you'll get 1.45. Anything outside, it shouldn't round to 1.45. Now something you might have noticed is that with our upper bounds, if you actually take the value of our upper bound and round it to 3 significant figures, you won't get what we want. So if you take 1.455 and round it to 3 significant figures, you won't get 1.45. So if you take anything just below it, for example, 1.4549999, and then keep on going forever, and round this to 3 significant figures, you will get 1.45. However, it's not practical to write out an infinite amount of 9s. So by convention, we round that, and we'll take this value as the upper bound. You can see here I've got a less than sign to say, okay, let's not include this. However, for the bottom part, it's the lower bound, we've got a less than equal to sign saying, yes, let's include that. But I recommend practicing some simpler upper and lower bound questions so you really understand how it works. Great, so now we've got all we need to work out the upper and lower bound of the value of G. If I've got a big number, and I divide it by a small number, I'm going to get a big number. And now let's think, if I took a small number and I divide it by a big number, that's going to equal a small number. Okay, well, why is that relevant? We're working out the upper and lower bounds of G equals L multiplied by 2 pi squared over T squared. And it's like a fraction. We've got L on the top and T on the bottom. For the lower bound, we want a small number. So to get that, we want a small number divided by a big number. We've got L on the top and T on the bottom. So we want the smallest possible value for L on the top. So we're going to use the L lower bound. and we want the largest possible value for t on the bottom, so we're going to use the t upper bound. And we're going to take those values, sub it into our formula here to get the lower bound for g. So the lower bound for L is 51.95, and we're doing L multiplied by 2 pi squared. And remember, we're told to do pi as 3.142, and that's all squared. And we're dividing by t squared, and we said we're going to use the upper bound for t. So that's 1.455, and that's squared. And that gives us a value of 969.0181643. Now we're going to do the upper bound. And to get the upper bound, we want the biggest number possible. So it's a big number divided by a small number. So the way we get the biggest number on top is by using the L upper bound. And the way we can get the smallest number on the bottom is by using the T lower bound. So the value L for the upper bound is 52.05. And again, that's multiplied by 2 pi. So 2 multiplied by 3.142, all squared. And we're dividing that by t squared. The value we've chosen for t is the lower bound of t, so that's 1.445 squared. We get 984.3677853. And then we're done. We've got a value for our lower bound here and our upper bound here. So we get 1 mark here for working out the bounds of L and t. Another mark for rearranging to get g to be the subject. 1 mark down here for our working. And 1 mark if we get the correct value for the upper and lower bound.